Hello everyone, I'm Tam, and we are back with another Why I Think It Is. Mathematics allows you to see more. It I as I grew from a student, from middle school to high school to college, etc. Mathematics has definitely been the most kind of eye-opening subject for me. Initially, in middle school, high school, it feels like a chore to do. Like, oh, I have to like solve this equation or do this other thing. It feels like a chore. Probably because of the way it's being taught. But that's a different subject. So it feels more like a chore, something that has no real significance or I guess relevance down the line. And and to some degree, that's completely true because you don't actually need anything beyond like I guess algebra to be a billionaire. Most billionaire probably don't actually need to use calculus. Don't need to use any of that stuff. So you can still live a very fulfilling and enjoyable life without having delve into I guess higher levels of mathematics for what it's worth. So and to that end, to that capacity, it's completely true that you don't actually need higher levels of like mathematics. However, if you do take I guess the rabbit hole and continue to progress your journey towards mathematics, perhaps you want to be an engineer or a software developer, etc. You will go into very kind of like high level mathematics, the kind of spooky area, linear algebra kind of stuff, like spooky area, and partial differential equations, the whole shebang, like like reaching a point where even the equation looks very scary. Yeah, like you have no idea what half of this stuff even means. Like weird looking symbols, that kind of stuff. Anyway, so the point is not the point is that once you reach that level, the way you interact with mathematics kind of change. It's yes, you're just trying to solve the problem. However, you're doing this in a very kind of abstract way. You're doing this in terms of like a very abstract way, like trying to prove theorems, doing a very abstract mental gymnastics, and all of this mental like gymnastic like juggling, is trains you to uh, see through, I guess, see through the layers of reality of different situations. For example, there is this popular, like I guess, math problem where you kind of have to solve I guess the ladder here. So so there's a ladder leaning against a building. How long is a ladder? If the building is I guess from the top of the ladder to the end to the ground is like I guess 5 feet, and the the bottom of the ladder to the building is like I guess 4 feet, something like that. So you start to see things more abstractly, the solution to that problem is I think I guess 3 feet or something like that, using Pythagoras' theorem, a squared plus b squared equals c squared. So you start to see you start to solve that problem very abstractly. So kind of abstract away all the kind of like I guess nuances, generalize the problem, and then you realize, oh wait, I can apply I can apply directly the same solution or similarly some kind of like smaller variation, smaller niche cases to a different scenario. For example, I have a water bottle here, and I want to like I guess I want to create like a funnel, so that I guess the mist the water vapor goes down the tunnel, and then at the end and the tunnel it is like it's like like a pool, a kind of sink. So this could be like a water tower, a tank You know, like the water tower, the water tower that collects rain. That's like 100 feet tall, like the giant thing, and you stick a tube to it, and to I guess the nearby pond or lake, or I guess whatever water source that goes to the rest of the community. So it's exactly the same problem. Besides the fact that this is a water tower, and you have a metal pipe, it's exactly the same problem as the ladder and the building. It's the same thing. It's just it's just it feels different because you're kind of like dealing with different material, but it's really the same issue you're trying to solve. How long does this pipe need to be for me to do that? So that's the power of mathematics. So once you solve like one problem, you're able to like generalize the solution, you can then apply the same solution to similar problems. So shooting one bird with like 10 different stones. It's like no using one stone to shoot down like 20 different birds. That's how I would describe mathematics. And that's the power of mathematics, being able to abstract away the kind of nitty gritty, the detail, and actually see things for what they really are, the kind of substance, and then you can like I guess modulate it, change it around, and then you actually have a answer, a solution to the issue that you can apply across different different like niches, different like categories, like whatever it is, doesn't really matter because you've solved the problem at the very core, at the actual thing that actually matters. All these other niches are surface level detail that doesn't really affect the solution, nor actually contribute to the underlying issue, the underlying problem. So that's kind of the power of mathematics, and that's why physics works, because physics is based around mathematics. So it kind of like builds upon the mindset of mathematics, the kind of theorems. So that's why you can feel safe, mostly safe for most for like flying from one city to another, because all that is based around physics, yes, and more fundamentally mathematics.